Okay, so question 8 is about measuring reaction time. Danny holds a meter ruler above Ellie's open hand. She catches the ruler when he lets go of it without warning. They use the distance the ruler falls to work out her reaction time. Always good to read the stem of the question. Tells you a lot of information about what's going on. You've probably done an experiment like this yourself in the past. Okay, so here's the data from the experiment. Measure the reaction times. Danny calculates the best estimate of the true value of her reaction time. He uses this calculation to get 0.2 seconds. Is he correct? Justify your answer. Well, true value is usually take a mean, and what's happened here is he's taken a mean, but if you look, there's 4 numbers. He's left out the first trial, the 0.29 seconds. So when we're justifying whether he's correct or not for 2 marks, simple observations like the fact that he's left out the first trial are fine. So ignore the 0.29 because it's an outlier. Actually, that would get you both the marks here. Okay. You could also get the mark for explaining why it can be ignored. Okay, so the first trial might be a practice, or possibly explaining why you think it should be in there. So if there's no reason to get rid of this first trial, test number 1, then it probably should be included, and you should add all 5 together and divide by 5. So whichever one you go for, as long as you justify it properly, that's where you're going to get 2 marks from. Lots of people sort of getting 1 mark because they've said it's an outlier, but without really explaining in detail what's going on. Okay, so you need to identify the point that's ignored and state that it's an outlier. So for part B, we're comparing what happens before to what happens now. So Ellie drinks an energy drink. Half an hour later, Danny measures Ellie's reaction time again. Here are the results. So another 5 tests after she's drunk the energy drink. And the question then is, does drinking the energy drink affect Ellie's reaction time? And again, justify your answer, and it says use data from the tables. Whenever you see anything like use data from the tables, you must at the very least be quoting some numbers from the table and probably doing a calculation, especially when you look and see there's 3 marks here. That's quite a lot of marks to get for a fairly simple statement. Okay, so if they've calculated a mean before to get a best estimate, then it would be silly not to do it when you've got another data set to do it with. So just do what they've done in the first part of the question, and if you do that calculation with all 5 here, because there's not an outlier there, okay, then you get a mean of 0.18. 1 mark for stating that. Okay. Another mark for comparing the means. So 0.18 is less than 0.20, so it seems like her reaction time is speeded up. Okay. That will get you 2 marks. For the third mark, though, if we're comparing 2 data sets and we really want to make sure that there's a difference between them, so is there a real difference, we need to look at the ranges. Okay. Now, we've already seen that the average is lower for the second data set. So what we need to do is we need to look and see if the top end of this data set here, the 0.20, the highest value, is that higher than the lowest one from this data set. And sure enough, there it is, 0.18. The ranges overlap, and so there isn't a real difference between the 2. So that's the level of detail you need for all 3 marks there. There's not a lot of space to write that, so you need to be quite succinct and quite to the point, okay? But you do need to include a lot of detail to get all 3 marks, so do look out for that. You were also allowed to compare the new mean with the old range. What that means is that if you calculate the new mean and you get your 0.18, it is just inside the old range, okay? Because the bottom end of the old range is 0.18. So you could discuss that as well and say, well, it probably hasn't affected it very much, if at all. Okay, now for part C, it's talking about how they use the ruler to measure the reaction time. So, Danny uses this graph to convert distance fallen by the ruler into a reaction time. Explain how the graph shows the ruler is speeding up as it falls. 2 marks. So, whenever you get a graph, you must look at what is on the axes of the graph. Otherwise, you have no idea what you're talking about when you're describing the graph. So here we've got a distance time graph. Okay, distance on the y-axis, time on the x-axis, and you need to learn the facts about the different graphs. So, for example, the slope of a distance time graph gives us the speed. So that's 1 mark, okay? Because what we're trying to do here is talk about how the speed changes. So the gradient, the slope of the distance time graph tells us the speed, 1 mark, and then an observation about the graph itself. The the slope is increasing as the time increases, right? So if the slope is increasing as the time increases, that also means the speed is increasing as the time increases, okay? You can't just say, and lots of people did, oh, the line goes up, so it's getting faster. That's not enough, because if this was a straight line, it would still be going up, right? If we went diagonally straight up from one corner of the graph paper to the other, that's still a line that's going up, but that would be a constant speed because the slope of the line is not changing. So again, precision is what we need here if you're going to get all the marks.